Let us now discuss the interconnection of two-port networks. There are different ways in which two-port networks can be connected with each other. In such a case, what will happen to its two-port parameters? Okay. So first we will see the series connection. So how will a series connection look like? We will take two-port networks. Okay. So here we have the voltage we will take as, we will take network A and network B, and accordingly we will have the nomenclature. So here we will take V1A and here we will take V2A. What will this be? I1A and this is I2A. Then what about the B network? V1B, V2B, and this is I1B, this is I2B. What is meant by series connection? The current in both the networks will be same. So that means the current coming out of here, if it is connected like this, then the same current will flow through here. So that is why this kind of connection here on this side also we will connect like this. This kind of connection is called a series connection. Now what do we want? We want the equivalent two-port parameters of this entire circuit. Okay. So that means this entire part of the network we will consider as a single two-port network. And what is the parameters of this single two-port network? We cannot relate all of the two-port networks, but in a series connection, the easier parameter to deal with is the Z parameters or the impedance parameters. So why is that? You can see that this voltage will now be V1 for the new two-port network. For the new equivalent two-port network, the voltage on the input side is V1, the voltage on the output side is V2, the current flowing into the input port is I1, into the output port is I2. Okay. So now what is V1? This is equal to V1A plus V1B. Similarly, V2 you can write as V2A plus V2B. What about the current relations? There is a series connection. So I1A is equal to I1B, and this is equal to what? You can see I1 is flowing into this. This is equal to I1A. So we will take I1. Similarly, I2A is equal to I2B, which is equal to the equivalent network's output current. So these are the four equations. Now if you take the first equation, what will you get? V1 is equal to V1A. You can write in terms of the two-port networks of network A. Okay. So this will be Z11. A we will take subscript to represent the network A into I1A plus Z12A I2A. Now this is the expression for what? V1A. Next, what about V1B? V1B you are going to get Z11B. Now we're talking about the B network. So the same equations, but the subscript instead of A you will have B. So I1B plus Z21B into I2B. This is for V1B. But we know that I1A and I1B, they are both equal and equal to I1A. So you can rearrange this equation as Z11A plus Z11B into I1 plus Z12A plus Z12B into I2. So now this will become the new Z parameter Z11 and this will become Z12 because we have got the first Z parameter equation. V1 is equal to something into I1 plus something into I2. Now this something will be Z11 and this something will be Z12. And you can see that Z11 is the addition of the individual elements of the individual two-port networks, network A and network B. You will write in the matrix form, it will become more clear to you. Similarly, V2 also you are going to get Z21A plus Z21B. This is similarly, I am writing the final result. I1 plus Z22A plus Z22B into I2. So you're going to get V1 V2 is equal to Z11A plus Z11B, Z12A plus Z12B, Z21A plus Z21B and Z22A plus Z22B, okay, into I1, I2. So what will be the equivalent parameters? What did we get? The equivalent parameters will be the addition of the individual impedances, okay. So for a series connection, we can add the impedance parameters. Next is parallel connection. So what will happen in a parallel connection? The voltages across the two two-port networks should be same. So that means this is one two-port network, we will name it as network A, and the second two-port network we will name it as B. For this we have the terminals I1B, this is V1B, V2B, and here you have I2B. Similarly for this network, you will have I1A, V1A, and here you have I2A, V2A. Now for the parallel connection, V1A should be equal to V1B. So how then will the terminals be connected? You can connect this and this together and you can take out the common terminal. Similarly, here this will be connected to this and you can take out the common terminal, okay. So now you have V1 which is equal to V1A which is equal to V1B, and this current will be equal to I1. Similarly, here we have positive terminals you will connect and the negative polarities you will connect, and both of these you will take, so that V2 is equal to V2A is equal to V2B, and the current here is I2. Now what are the equations that you can write here using KCL? You can say that I1 is equal to I1A plus I1B. See, at this terminal you have I1 is flowing into this node, I1A is leaving, I1B is leaving. Similarly, I2 is equal to I2A plus I2B, okay. So just like in the previous case, I1A, now you can express in terms of the voltages using what? Admittance parameters, right. So we will do one example. I1 is equal to I1A, you can write as Y11A V1 plus Y12A V1A, right, plus Y12A V2A, okay. This is I1A. So you can write here I1A. Similarly for I1B, what will be there? Y11B, only the subscript A will change to B. So this is V1B plus Y12B V2B. So this is I1B. Since V1A is equal to V1B, you are going to get the final answer Y11A plus Y11B into V1 plus Y12A plus Y12B into V2. Similarly, you can write the expression for I2. What will this be? Y21A plus Y21B into V1 plus Y22A plus Y22B into V2. So these are the two equations that are required. So we can see that we got the admittance parameters of the equivalent parallel connection as the sum of the admittance parameters. So here you can draw this also. This is the entire two-port network, equivalent two-port network, for which we want the admittance parameters, okay. So we can get any parameters, but admittance parameters is easier to get in the parallel connection. Just like in the series connection, the Z parameters was easier to get, okay. So what will be the expression? The equivalent admittance parameters is equal to the sum of the individual admittance parameters. And finally, another major connection is the cascade connection. So that means the output of one two-port network will be given as the input to the second two-port network. So let us take a network, two-port network A here. And here we have a two-port network B. So this has the input port V1A, I1A, and the output port is I2A, V2A. Okay, and similarly for this network, this is V1B, I1B, I2B, and V2B. Okay. So now what is the connection? Cascade connection is the output port will be connected to the input port of the next network. Okay. So now the equivalent connection is two-port network is this. Here it is easier to get the ABCD parameters or the transmission parameters. So we will mark these equations first. This is V1, this is I1, input side voltage and current. On the output side, current is I2 and the voltage is V2. Now we know that V1 and I1 will be equal to V1A, because V1 is equal to, can write here, V1 is equal to V1A, I1 is equal to I1A, and similarly I2A is equal to minus I1B. See, at this point you have both the currents are in the opposite direction. So I2A is equal to minus I1B. But what about the voltages? V2A is equal to V1B. What about the output port? I2 is equal to I2B and V2 is equal to V2B. Okay. So that's why V1 I1 matrix will be equal to V1A I1A, and this will be equal to, you can use the transmission parameters here, A, BA, CA and DA into the output side parameters. What are they? V2A and I2A, minus I2A, remember. Okay. So now what will this be? These ABCD parameters will be as it is. Now V2A and I2A we will write in terms of the next two-port network, V1B and I1B. What is V2A? V1B. And what is minus I2A? It is equal to I1B. Okay. Now once again, this is the input side voltage and current of network B. Once again, you can use the transmission parameters. So what will be the expression that you're going to get here? You will get the product of both the transmission networks. V1B into I1B is given by AB, BB, CB and DB into V2B minus I2B. Okay. So you can see that this is the equivalent parameters. So this is V1 and I1, and similarly V2 is nothing but V2B is nothing but V2, and minus I2B you can write as minus I2. Okay. So in a cascade connection, what is going to happen? The transmission parameters will be the equivalent transmission parameters you can get by the product of the individual transmission parameters. This is for the cascade connection.